Drinking from the data fire hose? Welcome to the party. Luckily, a whole host of solutions have been rolled out to address the size, scale, and scope of data movement projects. Yes, the cloud data warehouse is a common target, but what about all those other systems? Reverse ETL is now taking hold as companies look for ways to hydrate their systems with enriched data. Another alternative is data virtualization, a discipline that seeks to dynamically provision data access where and when it's needed. Find out more on this episode of Future Proof.
The future is here already. It's just not evenly distributed. Yet. Today's world teems with innovation. The nexus of hardware, software, and human ingenuity promises a revolution in possibilities. What does tomorrow look like? Witness Future Proof.
Yours truly here, Eric Kavanaugh. I'm very excited to be talking with a couple experts about data integration today. Faster, leaner, better, modern data integration. And, folks, I have to say, we're in year 16 of DM Radio, and it was in year 1, way back in 2008, that I remember really trying to wrap my head around the amount of ETL that gets done in large organizations. And of course, that stands for extract, transform, load, which was the go-to way, still is, quite frankly, for many organizations, of moving data from one place to another. You extract it from one system, you transform it to fit a schema, to fit a particular target system, for example, like a data warehouse typically, and then you load it into the data warehouse. Well, about 16, 17 years ago, something came out called ELT, which is just a slight variation on that. You extract it from one system, you load it into the other system, and then you transform it there. Synopsys was a company that did that. They got bought by Oracle, as I recall. And that was clever. And it got very clever when we got into the world of the cloud. And the reason is because primarily transformations take compute power. Transformations can be difficult to do. They take time, they take effort. And in the cloud, you have this scale out capacity for compute. So you can just extract the data, load it into the cloud environment, and then where you've got all that compute, bang out all your transformations and get your data where it needs to go. Well, there's also something called data virtualization, I should say, which also is not new. Data virtualization has been around since 2005. I think a couple different vendors, Composite Software, a company called Denodo, they've been doing that for a long, long time. Informatica has some data virtualization functionality, as I recall as well. And historically, that was mostly in the form of intelligent caching. So you would figure out that this group of users is going to be doing queries on this data set, let's say the first of the month, for example, and you would provision that ahead of time. You'd make sure to load some data into a cache so it's there ready to go for these queries. It's pretty a manual process by and large, not terribly dynamic, but that in and of itself was great or good at certain things. But these days, there are much more robust versions of data virtualization. So we'll be hearing from Nick Golovin from Data Virtuality and also from Taylor McGrath of a company called Rivery. They also have a very interesting solution that took a demo probably a year and a half ago, and it was very complete, very comprehensive. It gives you a sort of management, a control plane to get data, to do the transformation, to visualize that, to point it in a certain direction. So you have kind of like your grand central station for data movement, and the engineers can see where it's coming from, where it's going. In the last couple of years, we've had this explosion of what's called data observability, and that's primarily geared around pipelines and data coming into a system. Is it coming in the way it's supposed to? Is it coming in at the right speed? Are we seeing the kind of values we normally want to see? It's also important because of Kubernetes, which we've talked about before on this show, which is sort of the de facto new way of building enterprise software, an amazing project that came out of Google and has really taken over. But with that long-winded introduction, let's bring in our first guest, Taylor McGrath from Rivery. I love that platform, Taylor. It's very cool, and it gives that visual representation of what's happening. And that's what people need to wrap their heads around what's going on. It also just helps you get the job done. But tell us a bit about yourself and what Rivery has been working on.
Sure. Yeah. Hi, Eric. Hi, everyone. Happy to be here. So I'm Taylor McGrath. I am currently the VP of Solutions Engineering at Rivery. And Rivery is what we call a complete SaaS ELT platform. And I know that's like a lot of words jumbled. into one phrase, but what it means is, or essentially a SaaS or fully managed software that kind of fully completes that like ELT journey. And really what the foundation or core of the product is data pipelines. So it really acts as your data pipeline hub for anything from ingestion to native sources to custom sources. And we operate in an ELT mindset. So getting that data into a cloud data warehouse, allowing for pushdown SQL, even now fully managed Python as well, serverless Python, and then also having the capability to leverage data pipelines to push data out of a data warehouse. So back into operational systems, for example.
Yeah, so-called reverse ETL, right?
Right. Reverse ETL, I think, was the first kind of coinage. Now you hear like data activation, for example, is another phrase. But yeah, exactly.
Well, and this is, you bring up a really good point here. So this reverse ETL or data activation, I do like this concept of activating your data. Basically, what Taylor is talking about is that you pull all this data from your source systems, like your ERP system, your product system, your customer systems, for example, maybe web tracking, whatever it is you're trying to do. You pull that into a data warehouse or a data lake, or now there are lake houses. They have all kinds of interesting terms they're using to describe what they're doing. But the point is, in that environment, that's where you're doing your analysis. And that's great, and you learn things. But historically, the value of that was then generated by creating a dashboard, something that someone could look at and understand the business and then go make some manual change. Well, what you really want to do is take those insights and just fuse them back into the operational systems where work is getting done. And that's kind of the whole movement of this activation or reverse ETL, right?
Yeah, totally. I think like when you think about like traditional analytics, and there's still plenty of this, right? This is still kind of a foundation of like when a company starts their data journey, it's like, hey, I need data, I need some reports, I need some dashboards for like an executive level view of my company. Like who are our customers? What is our revenue? Like kind of these like basic questions to understand about what you're doing as a business. But then when you think about like taking it a step further and you hear like, powered by data, driven by data, like what does that mean? You think about it in the form of like workflows, like an operational employee, whether that's a salesperson or a manager of some sort, like in their day to day, how are they leveraging data? And with the traditional case, it might be something like, okay, I'm looking at a dashboard, I see some trend, I've done some analysis. Now I'm going to go back into my operational system, what I work in every day, maybe my CRM, my marketing platform, and do something, take some action. So I think what reverse ETL does is it kind of takes away the step of like the dashboard and puts everything into that operational system. But with that said, I'll say like this isn't necessarily a new concept whatsoever. I think for decades we've been sending data to operational systems. Now, albeit that might have been manual, that might have been with like homegrown code. But I think that the change here is really like when you think about the modern data stack and all these kind of categories that have come from that, and also the rise of SaaS products, I think this has naturally become its own category. And with, kind of the take or stake that like cloud data warehouses now have in the data industry, like leveraging your source of truth that you're building there to send back to systems has never been like easier. So I think that's really like why we've seen a rise of this and why we're seeing kind of all of this new, call it marketing, messaging, whatever, around activating your data, because I think it's never been more easy to do so.
Yeah, and I'll throw out an analogy here, and then we'll bring in Nick here in a second. But I remember doing an interview, 32 years ago, right out of college. I talked to a guy from the Illinois Department of Transportation, and we were talking about planning highways, right? So your data pipelines, that's like your highway through various suburbs, perhaps, to go get to your destination. It's coming from this location, it's going there, et cetera. And I remember him telling me that according to, I think, federal statute even, you're not allowed to plan for future traffic. You only have to plan for the traffic that you have now, which is a bit frustrating because they want to, get the job done at once. But you couldn't really do that. But now you kind of can. And the reason I mention this is because what happens when you open up the highways and you get more lanes, what happens? You get more cars. When things can go faster, when things can go easier, you get people using more and more and more data. So the more we open up these channels and the more we refine the pipelines and open up the capabilities to move data, the more data is going to be moved. What do you think?
Yeah, for sure. I think, it's never been easier. And I think, like, honestly, for some companies, it's a blessing and a curse, right? Because we have, like, it's very easy now with these SaaS platforms to spin up a trial, start doing things, point and click. But and even the kind of idea of ELT is like, let me just replicate my raw data and then deal with it downstream. So I do think there's kind of been this back and forth, especially of late with market in the state that it's in, of do we need all of our data, or we need to focus first and foremost on just the things that we need, just the lanes of the highway in your analogy, that we need for whatever traffic, because not all traffic, in the land of business value and getting business value from data, right? Like not all data is equally important. So when resources are not cheap, like they were, when money is not cheap, like it was 1-2 years ago, right. It's a different ballgame. But I think, like, the flexibility you get from these tools and the East to set things up, I think, is definitely an advantage, and is a fair argument when you're talking about, even now, with the market in the state it's in, companies' budgets in the states that they're in. Yeah.
Right. Well, we have to keep all these things in mind. You make some really good points there. Not all data is created equal. Not all data has equal business value. And when budgets get tighter, we do have to pay more attention to where we're spending money. But that does get back to this observability stuff too. So we are getting closer and closer. It's really kind of fun to watch as we're getting more and more able to understand what things cost. Of course, in this new concept of data mesh that we'll be talking about in a not too distant show, part and parcel to all that is a strategy for being able to account for things better, for being able to understand how much things cost. And I'll use that as a segue to bring in Nick Golovin from Data Virtuality. Nick, you folks are doing this data virtualization stuff, and I think you're really sort of a poster child for data virtualization 2.0. But tell us a bit about yourself and your company and what you folks are able to do.
Yeah. So I'm the founder of Data Virtuality. And what we do is essentially based on the technology of data virtualization. And I can explain it in a technical way, but actually, Eric, you gave me a very nice way to, describe it in a non-technical way, because you were mentioning those lanes and all this traffic which goes around. Mm-hmm. Those morning hours when everybody's driving to their offices. But what if some of the people were just able to work from home and not drive anywhere? And that's essentially what our company is about, because you also mentioned all this moving data. There's also costs, you need to build all those things, you need to move this stuff and so on. And what we do is we allow some data to work from home. Basically, we allow, yeah, I mean, I love it too.
That's
brilliant. You gave it to me. and the more I think about it, the more I like it. So basically, it's a kind of teleworking for data, right? And as you mentioned, we didn't invent the technology of data virtualization. It was there before. So like this general idea of, we don't need to move all data. We can just talk to some data, connect to some data, and use it. It was there. But like I would say, like before data virtuality came around, it was a kind of pretty religious relationship between people who drive to office and people who work from home. So it was like it's either the one or the other. So what we recognized is that to get the job done, to get people to do the work, to get data to do the work, some people still need to drive to the office. Maybe they work for automotive, they work for some verticals where you need to be there. And sorry for jumping back and forth. In the case of data, sometimes you cannot just connect to things where you need, for example, to historize the data over some time. Like, you need to build a slowly changing dimension, for example, or you need to bring the data over to cleanse them and transform them in a very special way. You need to bring them in. But for other data, you might just as well go and just get them from where they live, and like kind of continuing this analogy, which, I mean, the more I talk, the more I love it, to be honest. In the recent time, we also have cases where some special people may fly in. I mean, hopefully there'll be more in the future. And this is where we are talking about technologies for connecting data, such as streaming data or change data capture. And that's what essentially data virtuality is about making it possible for all those things to work together to get the job done, all the data to get the job done, not really thinking about how it happens behind the scenes. So some people work from home, some data work from their source systems, some people are some data is stored in the central database, some data come in via stream, and so on. And you can still, with our software, you can still model on top of all this and provide this to users and use cases in a uniform way.
Talking to Taylor McGrath from Rivery and also to Nick Golovin of Data Virtuality. We're talking about data integration, getting data from source to target. Pretty important stuff. Years ago, where this all kind of started is we realized that we could not query operational systems like your ERP systems, enterprise resource planning, the systems that drive business, that actually track the delivery of products and all these kinds of things, which when you get to be a company like Nestle's, for example, there's a whole lot of product to track around. You got to stay on top of all that stuff. And you couldn't analyze those systems. You couldn't do an analytics on them because they weren't designed for that. Software, it's very important to understand the design points, what you're trying to build with software, because there are lots of ways you can do it, but to know what the kernel is, what you're really trying to accomplish, is very important. And then you typically build on top of that. And then, of course, in the last few years, we saw lots of vendors coming in refactoring their software to run on Kubernetes, which is container orchestration. It's interesting because we're talking data virtualization. A lot of people understand virtualization like VMware, which was the first wave of this stuff. And that was absolutely fascinating. And those folks came along because they realized that in data centers, a lot of these computers, the compute was not very active. So you're thinking to yourselves, wait, why are we, if the CPU usage is only like 10, 20%, that's not a good sign. Now we're paying for all this stuff and not getting the value. So virtualization came around as a way to optimize the compute and optimize really the value that you got from the hardware. And data virtualization, maybe I'll throw this over to Nick Golovin, since that's your space. That's really, it's analogous, but it's designed to optimize the value of your data by getting the right data to the right place at the right time without having to do so much of the heavy lifting. Is that about right, Nick?
Yeah, exactly. So it's actually a bit less about optimizing purely technical things like optimizing CPU usage. It's much more about optimizing the time to solution for the companies, and also the amount of work people need to get their work done. I mean, in a way, data virtualization has been around for a very long time, but we actually like to now, since this, as you did just now, it gets compared a lot to the server virtualization. We actually like more the analogy of data OS, kind of data operating system. And the analogy works like this: in on your laptop or on your mobile device, you have lots of technical pieces which somehow work together. Do different things, have some data on them. But when you use your laptop, when you use your mobile device, you don't have to think about all those technical things, right? So you have some interface, and this interface, you can interact with it, do things, search for applications, and it can help get your work done, like get your applications running and so on. And this is why we like to think about what we do as a kind of data operating system, not in the sense like, it's a Linux clone or something, or you can run it on your laptop, but more in the sense of this analogy, you don't have to know what exactly technical parts you have there and how they talk to each other, but you can use it for your things without getting too technical about how it's exactly done behind the scenes.
Yeah, and that's really, really important, because I think, let's get back to the cars analogy. I'll throw this over to you, and then we'll bring Taylor back in. You don't have to know how your car works to know that your car works, right? Like, you don't really have to care how the carburetor is doing, what the pistons are firing. I mean, you can if you want to want to get into the weeds and really understand it, that's great. But even that's getting harder these days, because the cars are very specialized, the engines are very specialized, you have special tools that you have to use to be able to work on them, to even open them up and get to them. For example, you need special tools to do that stuff. That's great for the mechanics. And we do sometimes want to understand the inner workings, the infrastructure, whether from an audit trail perspective or some other reason. But the business user doesn't care. The business user wants to be able to quickly grab a piece of data, throw it at some system, at some model or a schema or something to kind of better understand it, and then really infuse that data, or as Taylor is saying, activate the data by feeding it at a particular time to a particular business process, like a customer lifetime value score, for example. That's a very simple one, which anyone in a call center can really benefit from, because if you see that this is a very high value customer, you're going to be on your best behavior, and you're maybe going to deal with them getting a little bit upset with you. Whereas if it's a very low value customer, you're gonna be like, I'm sorry, sir, there's nothing we can do for you. But the point is, you're enabling the business to act more intelligently without having to worry about which tool to use to get to that part of the engine. What do you think, Nick?
Yeah, absolutely. That's very right analogy. So you just drive, and you don't have to, you then have to push your gasoline through the tubes, so to say. Well, that's what you want to do at the end, right? Drive and not think about the workings inside. One thing where maybe this analogy could be a little bit extended, because with a car usually you just drive. So I mean, it's kind of one use case, but what we see in our situation, there's a multitude of use cases that are growing. So for example, a customer lifetime value would be one score, which could probably be like, historic value. But for example, our customers, customer, that's different, like customer in the sense of companies, they are also using us for other use cases. Over there are all kinds of dashboards or feeding the data into AI models. But there are also operational use cases, for example, calculating something which is called intraday liquidity risk, where by law you're obliged to, give you live data, or near live data, or calculating a live credit score, for example, in an online store. So all these kinds of things. So it ranges from, it's not only about driving, it ranges from analytical to operational use cases, what people can do with the data coming from such a platform.
Sure, and learning from the data too. You learn when you look at the data, you start to understand what can happen. And when you can visualize these things, and I'll throw this over to Taylor. There's one of my favorite philosophers, Ludwig Wittgenstein. He said, some things cannot be said, they must be shown. And his point was, at a certain point, when you try to articulate in words what a particular thing is, it can get kind of confusing. And if you don't believe me, folks, give yourself a little test. Just think about having to write down instructions for finding your keys and putting them in the car and turning it and putting the seatbelt on. It's going to take you a whole heck of a lot of words to do that. Or you could just show someone, here, I go like this and I go like that, boom. Like, oh, I get it now. So sometimes words are very cumbersome and also ambiguous, whereas visualization is much more clean and allows you to understand, okay, I'm pulling this data from here, I'm transforming it by enriching it with this customer lifetime value, then I'm delivering it over to this system over here. And when you can watch all that, well, that's when you can make sure the trains run on time and the customer service is good, and they're acting on fresh information. And that's the other, I guess, curveball I'd throw at you, Taylor, is that for certain use cases, you must have fresh data. Sometimes yesterday's data is not good enough. And that's another one of these sort of characteristics or requirements that goes into designing your data pipelines and optimizing them to make sure that the ones that have to work in a certain time period are working in a certain time period, right, Taylor?
Yeah, totally. And I think I think Nick said it, like the differentiation between operational and analytical is key there. I think, because we're thinking analytical, right? That's probably something that can be like batch loaded. We're doing analytics at some time, we're digging into data, we're trying to find an answer or an insight. Whereas operational, plenty of times those are things that need to happen in real time or near real time, where a decision needs to be made, and it's crucial that happens at that certain point. And so even the example you gave, like with a call center, right? Like, and maybe the under the hood of getting the customer lifetime value is some analytics. Like maybe it's a recommendation engine or something that's happening, like some sort of AI modeling that's even getting us to that number, or maybe more than a number. It's actually a recommendation that we're giving a call agent to say, like, hey, because of XYZ, like this is the talk track you should use with this customer. Maybe it's that smart, but like in a phone call, right, that needs to be real time. So what that means is kind of all the pieces of the puzzle that build to that need to also be in real time, in terms of kind of already having the data, or getting in real time, streams of data, but then also being able to do, and this is something that I think is still very much evolving, and there's been strides made recent, is like, transformations in real time, right? Like what that means is you actually have to retain some form of state of the data to be able to transform it. And so yeah, I think from what I've seen, even over the last year, there's been crazy developments around kind of how this can be done, and also how easily it can be done, right? And some of these kind of tools that are part of the modern data stack that now like your kind of regular old data practitioners are doing. And what that means is that now, right, the tools and the things we're using to do these traditional analytics, it's becoming more and more of a Venn diagram or crossover into the operational world. In terms of there's terms out there like operational analytics, where like there's a combination of what you're doing is operational, but really it's analytical in essence, where you're doing some sort of like analytics under the hood to even get you to that operational